Hello dear students, today we will discuss the eigenfunctions and the eigenvalues for a particle in a deep potential well, and this is the continuation part of our previous lecture. So let us consider the first case, that is n is equals to 1. So the eigenfunction is, we have already derived the eigenfunction, that is sin is equals to root of 2 divided by a sin n pi divided by a into x. In this equation we have to substitute n is equals to 1. So when you substitute n is equals to 1, that will be eigenfunction for the first state, psi 1. So psi 1 is equal to root of 2 divided by sin of pi divided by a into x. So in the above equation, psi 1 will become equals to 0. The psi 1, this entire quantity is going to be 0 for both. For both, when you substitute x is equals to 0, psi 1 is going to be 0. When you substitute x is equals to a, when you substitute a and this a will get cancelled, it will be sin of pi. So sin pi is again, it is going to be 0. So we will get psi 1 value 0 for both x is equals to 0 and x is equals to a. Now the same psi 1 value has maximum, the psi 1 value has maximum value for x is equals to a by 2. So when you substitute it as a divided by 2, x as a divided by 2, this a and this a will get cancelled and you will be left with sin of pi divided by 2, that is maximum value root 2 divided by a. So psi 1 has maximum value for x is equals to a by 2. So we can plot psi 1 versus x, which is shown as below. So here you can see the plot of psi 1 versus x. So the psi 1 value is 0 for x is equals to 0 and x is equals to a, and it has a maximum value at a divided by 2. So this is the width of our box or the potential well. So if x is equals to 0 and x is equals to a, psi 1 is a lower value, then the probability of finding the particle at these 2 points will be less, and the probability of finding the particle will be maximum at the center of the potential well. This is the meaning of this equation. Now similarly, if I take modulus of psi 1 square, that is probability density. So when I take the probability density, it will be like this. The probability density versus x will be plotted like this. For x is equals to 0 and x is equals to a, the probabilities will be less, and at the center the probability is going to be more. Now for the same ground state, if we write the energy eigenvalues for ground state n is equals to 1, we will be having, so this is our energy equation which we have derived yesterday. En is equals to n square h square divided by 8 ma square. So here n you need to substitute 1. So when you substitute n is equals to 1, it will be h square divided by 8 ma square. This is denoted as E naught, that is the ground state. Okay, so we will go for the second state now. So for case 2, n is equals to 2. So in the again equation, psi 2 is equals to root of 2 divided by sin of 2 pi divided by a into x. So here psi 2 is going to be 0. The psi 2 is going to be 0 for the values of, if we substitute x is equals to 0, the psi 2 is going to be 0. If I substitute x as a divided by 2, in place of x if I write a divided by 2, this 2 and this 2 will get cancelled, this a and this a will get cancelled, again you will be left with sin pi, again that is going to be 0. So psi 2 is going to be 0, and it is going to be 0 for a. If I substitute x value as a, this and this will cancel, and again you will be having sin of 2 pi, that is going to be 0. So the psi 2 value is going to be 0 when you substitute x is equals to 0 here, x is equals to a by 2 here, or x is equals to a here. Okay, similarly, but psi 2 has a maximum value for, if I substitute the x value as a by 4 here, So the psi2 is going to be maximum. And if I substitute x is equals to 3a divided by 4 here, it is going to be maximum. So let us plot the graph for psi2 versus x. So it will be like this. You need to show psi value as 0 for the 3 positions, x is equals to 0, x is equals to a by 2 and x is equals to a. For these 3 points it will be 0. Then the maximum value we have get it for a by 4 and 3a by 4. So this a by 4 is the maximum value and 3a by 4 is the maximum value. Now the same graph if I plot it for the probability density, so it is modulus of psi square. So all the positive value or negative values you have to take it in terms of positive. So the probability density will be maximum at a by 4 and 3a by 4. Now similarly, if you write the energy eigenvalue for n is equals to 2, so we will be having E2 is equals to 4h square divided by 8ma square. So it will be n square h square. So in place of n, if I substitute 2, it will be 4h square divided by 8ma square. So this I can also write it as E2 is equals to 4 into E1, because our E1 equation is h square divided by 8ma square. So if I replace this 4, it will be E0. So I can write 4 into E0. Similarly, for E3 you can write 9 into E0. So on and so forth. You can just go on finding when you substitute the different values of n. Starting from n is equals to 1, n is equals to 2, n is equals to 3. You can just go on calculating the eigenvalues and the eigenfunctions for the different states. Okay, thank you.